All right, algebra students. So you can jump around in this warm-up review. You can just review the stuff that you want to, work through the things that you think you need to know in order for your quiz to go well here in a few minutes. I'm just going to work through from the beginning to the end, and so you don't have to watch this whole video. You can kind of bounce around in it. All right, so let's go ahead and get going. Tell which relationship below is a function. Indicate whether your answer by checking the box, then fill out the rest of that box. If it's a function, give the domain and range. If it's not, explain why not. Okay, so here's the first relation. I'm looking at it, and something that I'm noticing, if I am being conscientious, is that this guy passes the vertical line test. So throughout the entire domain of the function, each input has exactly one output. And so I can be sure that, yep, it's a function. So now I need to look at its domain, and its domain is the set of inputs, which is along this axis down here. I'm going to make my pen slightly smaller. So the domain, I'm going to make a nice organized list. It looks like there's a point here at 1, 2, 3, 4, 5, 6, and 7. So 1, 2, 3, 4, 5, 6, 7. The range is going to be the set of outputs, and that's the y-axis. So I'm going to go through, and I'll get rid of this stuff because it's just my work. To find the range, I'm going to notice that there's a point here, and that's at 1. There's 2 points here at 2, points at 3, no points at 4. There's a point at 5, and then a point at 7. And so I'll make that list. 1, 2, 3, 5, 7. Okay, so let's look at the second one. So I'm testing again whether it's a function, and something that I'm noticing looking at it right off is that 0 is repeated, so is 2, and when they are repeated they are going to different outputs. So it's not a function. 0 has 2 different outputs, 4 and 64. And you can also give the example of 2 having 8 and 32 for its outputs, but really once you have one example, you're good enough. All right, so construct a table and graph that are both non-functions. So if it's a non-function and it's a graph, it has to not pass the vertical line test. So I am already done because I have something that will not pass the vertical line test. Boom. And so I can stop there, or I can make more points if I want, so long as I have at least 2 points that are lined up vertically. All right, non-function here, I'll do x and y. I'm just going to do this. 0, 0, 0, 0, 0, 0. It's going to go 1, 2, 3, 4, 5, 6. Your example doesn't have to be exactly the same as mine, but the point is that the input 0 has a bunch of different outputs. That makes it not a function. Okay, let's keep going. For each of the tables, find the slope and y-intercept, then find the rule. Okay, so the slope, I know I have to find the change in y, so that's 6 plus 6 equals 12, and negative 2 plus 2 equals 0. And so the slope is delta y over delta x. Here's my delta y, here's my delta x, and so I do plus 6 over plus 2, which reduces to 3 over 1, which I can just write as 3. Okay, so my y-intercept occurs when x is 0, so there it is right there. I'm going to write that as the point 0, 12. And so then I can write the rule, and so y-intercepts are constants, so it's not going to have a variable next to it. And I should, pardon me, I should write this, I'm just out of habit, I should write this as a function rule. F of x equals the constant 12, which is going to be by itself, and then the slope says add 3 every time for x. Okay, again, let's start with the y-intercept because it's right there at the top. Y-intercept is 0, 36. All right, so this goes up 1. This goes 36 minus 6. Isn't going to get there, excuse me. it's going to be 36 minus 8 gets me to 28. And so delta y over delta x is minus 8 over plus 1, which simplifies to negative 8. And so my slope is negative 8. And my rule, g of x, I'm changing the function name because I've already used f. G of x is equal to the constant 36, because that's the y-intercept, no variable next to it. I'm going to take away 8, my slope, for every x. Okay, let's keep going. This one may be a little bit more complicated. Let's look at it. Okay, I see the y is going up. I'll zoom in here so I can write a little bit more precisely. The y here went down 4, so 0 minus 4 is negative 4. 2 plus 2 gives me 4. So I'm going to do my delta y over delta x. I guess I can do that right here. Delta y over delta x equals negative 4, because that's my delta y, over delta x plus 2. That reduces to negative 2 over 1, which is the same as negative 2. So my slope is negative 2. Now my y-intercept, don't be thrown off, this is not the y-intercept, and it's because x is not 0, that's y is 0. So we're going to count back a little bit farther. So let's go backwards. If I go down 2 in the x's, using the pattern that's in the y's, I should add 4, so I'll get to 4 at 0. Because 2 minus 2 is 0, and 0 plus 4 is 4. That matches the pattern that's in the rest of the table, and that indeed is my y-intercept then. So I have 0, 4 as my y-intercept. Now I can write the rule. H of x equals the constant 4 minus 2x. I'm going to go ahead and highlight my answers here because I'm going to use this as a key in a little bit. For those who want to just check their work, make it a little bit easier on them. Okay. Use a graph to find the slope, y-intercept, and function rule for the relationship that is graphed. Okay, so I think you guys probably tend to start with y-intercepts. I do too. So I'm going to look for the y-intercept. It's right here where it crosses the y-axis, and so that's 0, negative 2. And now I need to draw one of those triangles. So I need to find 2 points that I can be absolutely certain of their coordinates. Here's one. And then the next point that is perfectly clear is right here. And so my triangle is going to go up all the way there and to the right. And so I count the boxes, 1, 2, 3, 4, 5. So that's plus 5. And that's delta y. I changed in y. Delta x is plus 3. And so then my slope is delta y over delta x. So that's plus 5 over plus 3, which is just 5/3. Doesn't simplify, so I'll put that in as my slope. And then my rule is going to be, we'll say m of x is equal to the constant negative 2, because that's the y-intercept, plus 5/3 x. All right, moving along. Starting with the y-intercept again, there it is. It's 0, positive 6. And then this graph, the next point that I can be absolutely clear of, occurs all the way down here. So it goes over and then down. Okay, so my change in x up here is 1, 2, 3, 4, 5. So that's plus 5. My change in y is 1, 2, 3, 4, 5, 6. And notice that it is down 6. So change in y is equal to negative 6. So change in y over change in x for my slope is negative 6 over plus 5, which does not reduce, so my slope is negative 6/5. And so my rule, n of x, is going to be the constant 6, because that's my y-intercept, minus 6/5 x, because the slope always goes next to x, or the variable that you're using. All right, moving right along. Let's graph each relationship. And so I'm going to start by identifying the slope and y-intercept. The slope is next to the variable. So my slope here is negative 2/5. And then my y-intercept is the constant. And so that's 0, 7. And so to graph, I'm going to first graph my y-intercept. So I'll go up to 0, 7. There it is right there. And then my slope tells me delta y over delta x. So the change in y here is -2, which is the same as down 2 over, and then the delta x is positive right 5. So down 2, right 5. So that's down 2, right 5, and then I make my point. And I can get rid of the work there. So down 2 and right 5, I make my point, and then I can erase. Now if I want to go the opposite direction, I can go left 5, but instead of going down, I'm going to go up to stay with the pattern. It should stay a nice straight line. And so once I have that, I might be able to graph this last one here. I could make a fairly straight line that goes through all of them. Add those arrows at the end that show that the relationship has an unrestricted domain, and we should be pretty done. Okay, let's look at number 6. Okay, so this one, I can't tell the slope and the y-intercept right off, so I need to solve for y. And so to do that, I need to get rid of 2x. I'm going to take away 2x, and then I'll get -3y equals 6 minus 2x. Now I'll divide by -3, and so I'll get y is equal to 6 divided by -3 is -2. -2 divided by -3 is plus 2/3 x. Alright, so that means my slope is positive 2/3. My y-intercept is the constant 0, -2. Okay, so that means I can start at 0, -2 right there, and then I go up to right 3, because that's what this slope says. It says up to right 3. So let's do that. Up to right 3, there's my point. Up to right 3, make my point. Up to right 3, make my point. Now to go the opposite direction, I'm going to go down 2, left 3, down 2, left 3, down 2, left 3. And I can get rid of the steps because those aren't actually part of the graph there, and draw in my line. Cool. All right, let's keep chugging along. All right, Gary, the disgruntled accountant, is fed up with his job, as he should be. He told his boss to shove it and left. Now he's on the bus home and he's figuring out his finances now that he's jobless. He checked his phone to see that he's got $10,500 saved up. He should get one more paycheck from his job for $3,000. Then he will have to live off what he has until he runs out of cash. Looking through his bank records, again on his phone, he's able to tally that he spends $1,500 a month on essential stuff. Even though he usually spends more, it's on frivolous things he can do without now that he has to pinch pennies. And I just noticed a grammatical mistake. It's should be broken up with an apostrophe because it is a contraction there. Okay, so let's make a graph for the situation. So I think I'll have, he's spending per month, dollars a month. And so I think one of my variables here is going to be, and I'm going to make my pen a lot smaller so this turns out clear, months. And then it's going to be cash left. Okay, so looking at that, I think I'll just do 0, 1, 2, 3, 4, 5. And we have to figure out how much money he's got at the start. And so he's got $10,500. But he's also going to get that $3,000 check from his employer, and so he'll end up with $13,500 now that he's living without anything. Okay, and so then it says he spends $1,500 a month, so this should go down $1,500. And doing a little mental math here, that should give him $12,000. Down $1,500, that should give him $10,500, down $1,500, and that will give him $9,000, down $1,500, and that's going to give him $7,500, down $1,500, that's going to give him $6,000 after 5 months. And so I think I might need to get rid of this stuff so that I can label my axes. So I know I need to get up to 5 months here, so I'll do 0, 1, 2, 3, 4, 5, and then we'll just do 6, 7, and 8 here, and that's my months because it's the input or the independent variable. And now I'm looking at 0, and I need to get all the way up to 13,500. So I think what I'll do is I'll count by 1,000, so that would make this 4,000. Then I'll make this 8,000, 12,000, and this is 16,000, which is higher than we have, but that's okay. And I'll label this as dollars. Okay. So now I need to plot some points. So 13,500 is at 0. So there's 12,000. 13,000 would be right there. And so halfway between is 13,500. There we go. And then after 1 month, we're going to have 12,000 left. So that goes right there. 2 is 10,500. So there's 8,000 right there. 9,000, 10,000, and a half goes right there. 9,000, which is 1 above 8,000. So there we go right there. I'm noticing the pattern. It looks like it goes down 1.5 over 2. Down 1.5 over 2 is going to be right there. And I'll just double check. That should be 7,500, and that's 500 less than 8,000, which is good. So I can just continue the pattern all the way down because the pattern seems to be working. And then after 8 months, he'll have something like $1,500 left. Okay, write a rule for the situation in function notation. So I can see the y-intercept. You might remember from my work before that every time a month went by, it took away 1,500. So my change in y over change in x is take away $1,500 for 1 month, which simplifies to minus 1,500. So f of x, which I've already used, excuse me, let's make it c of x is equal to, we can even do better than that, I think. Let's do c of m since we have months. C of m is, we start at 13,500, the constant, minus $1,500 a month, and so m equals number of months. What is the slope of your function? We just talked about it. It's negative 1,500. The y-intercept, we pointed out, is 0, 13,500. And now what is an appropriate domain of this function? Well, we're only looking into the future, so positive numbers for the number of months. It looks like he's only thinking about from month to month, so in this case it'd be positive numbers that are whole. And at some point he's going to run out of money, and I can point this out. After 1 more month, if he were to go to 9 here, he'd be out of money. So I think it should be between 0 and 9. And that's just thinking about what months are relevant for the function for this fella, the disgruntled accountant. All right, hopefully you found that helpful. Good luck on your quiz.